In this video, I will show you how to take a complex piecewise function whose graph is given and turn it into a piecewise function equation. And then we'll answer several questions about it, including domain, range, increasing, decreasing, etc. And then I will show you how to do a transformation of that function based on this rule. First, try to imagine what the parent functions are. So when you see a V shape like this one, you know that the parent function is absolute value of x. So that's what's happening right here. And this other piece over here, you can tell that's a parabola. So the parent function here must be x squared. So looking at the absolute value piece, let's go ahead and start with that. The vertex is still in the original place, 0, 0, so that hasn't changed. What has changed is this. Normally, the parent function goes up 1 over 1. So the first point would be here, and the second point would be here. Now, look and see where the points actually are. So instead of being at 2, this point is at 1. Instead of being at 1, this point is at 1/2. So every point is half the value that it normally would be. So that tells us that we are dealing with a vertical compression by a factor of 1/2. So this function is going to actually be 1/2 absolute value of x. So we'll use that to begin our piecewise function. 1/2 absolute value of x. I think I will use interval notation for the domains this time. In my previous video, I did inequalities. So what's the domain of this piece of the function? -infinity to 2. Alright, so -infinity to 2, not including the 2, so I'm going to use parentheses. See, that's an open circle. Alright, now I see that we have a single dot here. We need to get that into the piecewise function. Okay, so this dot is simply a value of 4. So we can say that the function will simply equal 4 when x equals 2. All right, that's not an interval, so I'm just going to say when x equals 2. Okay, and now the parabola. The shape of the parabola is the normal shape. I don't see any stretches or compressions. I can tell because based on the vertex, the next point is over 1 and up 1. So that's like the point 1, 1. And the next one is like having 2, 4, if I pretend this is the origin for a minute. So the points are following the normal shape. So all I have to worry about is the fact that this is moved to the right by 3. So that's why in the transformation I'm going to have x minus 3 squared, because this is what it looks like whenever you move to the right. Okay, so I'm going to put x minus 3 squared, and then the domain of that is from 2 to positive infinity. All right, not including the 2. So that is it for the piecewise function. What's the domain of the function? Well, I think it's going to be -infinity to positive infinity. Every x value is covered, including 2 being covered by that dot. So the domain is from -infinity to positive infinity. What about the range? The range goes from 0 to infinity. All right, there are no empty y values from a low of 0, and it goes up forever. So the range is going to be, wait, this should be a bracket though, not parentheses. So 0 to infinity, and I'm putting a bracket to show that the graph touches 0. So 0 is to be included. Now let's talk about the intervals of increasing and decreasing. Whenever you talk about increasing and decreasing, you should read the graph from left to right. Alright, so imagine that you're traveling this path from left to right. I would start off going downhill, okay, until I got here. And then I would go uphill for a while. And then there's a single point right here. But then I'm going downhill again for a short while. And then I'm going uphill again. Alright, so from left to right, I went downhill and uphill and downhill and uphill. Everywhere I just highlighted in pink is corresponds to a decreasing interval. Everywhere I just highlighted in green is going to correspond to an increasing interval. So think about the domain of each of these. So let's start with the increasing part. Okay, what is the domain of the increasing part? So notice this first increasing interval. The domain goes from here to here. That is from 0 to 2. And then there's a gap. And then the domain of this green part, so I'm doing domains, I'm sticking to the x-axis. It goes from 3 to infinity. So the green that I just traced onto the x-axis, those are the increasing intervals. Okay, so from 0 to 2, union 3 to infinity. Alright, always use parentheses when you're doing increasing and decreasing intervals. Don't include the endpoints. Okay, now let's do the domain for the decreasing part of the graph. So remember, we're doing domain, so I'm going to stick to the x-axis here. So the domain of this first decreasing part goes from here to here, and then there's another decreasing part from here to here. Okay, so that first interval is from negative infinity to 0. So it's decreasing from negative infinity to 0, union. And then it's also decreasing from 2 to 3. Always use parentheses for the increasing and the decreasing. For number 20, we are asked for the points of discontinuity of the function, and we need to identify them: infinite, jump, or removable. So we are looking for breaks in the graph, where if we were tracing this, we'd have to pick up our pen. There's only one break in the graph, and it's right here at an x value of 2. This is simply a hole. There's one missing point. So this is a removable discontinuity. Okay, so there is a removable discontinuity at x equals 2. Okay, last we are to graph the transformation of this piecewise function using this rule. So remember, any transformation happening outside the function is going to affect the y values. Okay, so y values. The y values are going to be affected by the 2 and by the -4. Anything happening inside the function is going to affect the x values. Whoops. So the x values are going to be affected by the -3. So I like to set up a table of values that I can easily use to track the transformations that are happening. So for that reason, the first thing I would like to do is come up with a set of points that I can use to guide me, some key values. So I'm going to use this as a point, this, I'll use this point. Okay, I need this point, this point, this point. Okay. All right, that'll be enough points. So here's my table of values. See if I can do that any straighter. Okay, so my first point is at -8, 4. And then I have 0, 0. And then I have 2, 1. All right, then it jumps to 2, 4. I'm going to need that point. And then comes the parabola part. Okay, so I'm going to have 3, 0, 4, 1, and 5, 4. Okay, so I remember that we have changes to the y values and we have changes to the x values. So I'm going to need a new y column and I'm going to need a new x column. All right, so the y values will be affected by the 2 and the -4. So I need to multiply by 2 and subtract 4. So on the table, that's going to look like this. 2y minus 4. All right, so I'm going to do that to all of these y values, and I'll record what I get. So these are my new y values. Now let's talk about the new x values. The only change to the x value is the -3. Now remember, this is actually a shift to the right 3. Because this is a shift to the right 3, when I modify the x values, I need to do x plus 3. So I'm just going to add 3 to all these x values. So now all I have to do is plot my new x values and my new y values, and that will really show me where the graph is. So I've got a -5, 4 is going to be right here, and then 3, -4 is going to be right here. All right, this represents this long stretch right here. All right, but we haven't finished the V yet, so we also have this point at 2, 1. All right, so we're talking about this open circle, but the new point is 5, -2. So 5, -2. So remember, this will be an open circle now. Okay. All right, so there you go. So that is the absolute value part. Next we have a single dot, all right, which used to be here, but now it's at 5, 4. So 5, 4, I'm going to have a single dot right here. So we've done the dot now. As we draw the parabola piece, 6, -4. So here's 6, -4. All right, remember the parabola really starts from this open circle, but it will go here. 7, -2 as the parabola begins to swing back up. And 8, 4. So the parabola piece is going to look something like this. All right, got a little janky in there, but you get the idea. That was supposed to be blue. So there it is. My transformed function should be very much like what you see here in blue. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.